two identical bodies are made of a material for which the heat capacity increases with temperature. One of these is at 100 degree centigrade while other one is at 0 degree centigrade. If the two bodies are brought into contact, then assuming no heat loss, the final common temperature is 50 degree centigrade, more than 50 degree centigrade, less than 0 degree centigrade, 50 degree centigrade and 0 degree centigrade. Suppose two bodies are body A and body B. Initial temperature of body A is 100 degree centigrade. Initial temperature of body B is 0 degree centigrade. Now, they are brought in contact. Final temperature of these bodies becomes T degree centigrade. T degree centigrade. Average temperature of A 100 plus T by 2 or 50 plus T by 2. Average temperature of body B will be 0 plus T by 2 T by 2 degree centigrade. Average temperature of A is greater than average temperature of B. Suppose let specific average specific heat capacity of A is S1 and average heat capacity of B is S2. Average temperature of A is more than average temperature of B and heat capacity increases with time. Hence, S1 is greater than S2. Heat given transferred by A अगर इसका मास is m और इसका भी मास m, ms delta T and m into S1 and delta T is temperature difference 100 से T डिग्री सेंटीग्रेड पर आया. Heat received by B will be ms2 T minus 0 is equal to mst. So, heat transfer by A will be heat received by B, ms1 100 minus T is equal to ms2 into T. m से m क्रॉस हो गया. 100 S1 minus S1T is equal to S2T, or S1T plus S2T is equal to 100 S1. S1 plus S2 T is equal to 100 S1, or T is equal to 100 S1 by S1 plus S2. S1 से न्यूमरेटर और डिनोमिनेटर को डिवाइड कर दिया, 1 प्लस S2 बाई S1. S1 is greater than S2, hence 1 plus S2 by S1 is less than 2. Hence T is greater than 50 degree centigrade. T will be more than 50 degree centigrade. This B is correct option. Next, a body cools from a temperature 3T to 2T in 10 minutes. The room temperature is T. Assume Newton's law of cooling, the applicable, the temperature of body after 10 minutes next will be 7T by 4, 3T by 2, 4T by 3 and T. According to Coulomb's law, d2 by dt is equal to k T2 dash minus T1. dt2 in change in temperature, जो फर्स्ट कंडीशन 3T से 2T में कन्वर्ट हुआ, एंड dt is time taken 10 minute is k, dt2 dash is average temperature of body 3T plus 2T by 2, and T1 is room temperature, that is T. T by 10 is equal to k 5 T by 2 minus T is equal to k 3T by 2, or k is equal to 2T by 10 into 3T 1 by 15. Suppose final temperature is Tf. तो सेकेंड कंडीशन के लिए इनिशियल टेम्परेचर is 2T. So d2 T2 will be 2T minus Tf, time is 10 minute is equal to k average temperature 2T plus Tf by 2 minus room temperature. 2T minus Tf अपॉन 10, k की वैल्यू पुट कर दी हमने 1 by 15, 2T plus Tf minus 2T by 2. Tf by 30, 2T minus Tf by 10, 10, 3, 6T minus 3Tf is equal to Tf, or 4Tf is equal to 6T, T final will be 6T by 4, 3 by 2T. Final temperature is 3T by 2, B is correct option. Next, coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Length of brass rod and steel rod are respectively L1 and L2. If L2 minus L1 is maintained the same at all temperatures, which of the following relations holds good? Suppose temperature increased is delta T. After increasing the temperature, length of brass rod will be L1 dash, and that will be L1 1 plus alpha 1 delta T, or L1 1 plus L1 alpha 1 delta T, L1 dash. Question number 1. Similarly, for steel rod, L2 dash will be L2 plus L2 alpha 2 delta T. Equation number 2. Difference of length is maintained. L2 dash minus L1 dash is L2 minus L1. यहाँ वैल्यूज पुट कर दी हमने इक्वेशन नंबर 2 and 1 से. L2 प्लस L2 alpha 2 delta T minus L1 plus L1 alpha 1 delta T will be equal to L2 minus L1. L2 minus L1 plus L2 alpha 2 delta T minus L1 alpha 1 delta T is equal to L2 minus L. L2 minus L1 से क्रॉस हो गया तो L2 alpha 2 delta T will be equal to L1 alpha 1 delta T. डेल्टा T से डेल्टा T क्रॉस हो गया, L2 alpha 2 is equal to L1 alpha 1. This C is correct option. Next, a piece of ice falls from height h so that it melts completely. Only 1/4 of heat produced is absorbed by the ice and all energy of ice is converted into heat during its fall. The value of H, latent heat of ice, is 3.4 into 10 to the power 5 joule per kg and G is 10 Newton per kg. This is latent heat. Suppose mass of ice piece is m, this is ground, or m is h height above the ground, this is h. So potential energy of ice will be mgh और इस एनर्जी का 1/4 हीट में कन्वर्ट होता है. तो हीट produced will be mgh by 4. The ice melts. आइस मेल्टिंग के बाद जो एनर्जी रिक्वायर्ड होगी दैट विल बी m into L. तो एनर्जी required for melting of m mass ice, that is m into latent heat. The heat produced and energy required for melting will be equal, mgh by 4 will be equal to ml, m से m क्रॉस हो गया, h will be 4l by g. L is 3.4 into 10 to the power 3.4 into 10 to the power 5 divided by 10, or 4 into 34 into 10 to the power 3 meter, or 136 into 10 to the power 3 meter, और 136 किलोमीटर. जो हाइट है आइस जिससे फॉल होगा दैट इज 136 किलोमीटर. बी इज करेक्ट ऑप्शन.